So hello and welcome to my YouTube channel. Today we are going to take up this problem. This is a very logical problem and a brilliant problem, to be honest. So it goes like, one day Bobby decided that it might be a good idea to take a nice stroll across the giant chessboard that he built in his backyard. He starts at the bottom left corner, walks in a straight line and crosses exactly 12 squares. Technically there are infinitely many possible directions that Bobby could have walked in. However, if we restrict Bobby's path to lines with slopes of the form a by b, where a less than b less than equal to 10 are positive coprime integers and the number of solutions is finite. Under this constraint, how many possible solutions are there? Now you can just pause the video here and try to solve it yourself. Go back to the question and just try to solve it yourself, or you can look at the solution here. Now, going to the solution, what the problem exactly asks from us? Well, it tells you that there's a point in the chessboard. Let's say this is a chessboard. So you start from the bottom left corner of this chessboard and you go walking across the chessboard with a constant slope, and then you'll have to understand how many boxes do you cross in your path. So basically the problem goes like this, that the slope of, let's say the slope of a line is m and the slope of the line is given, and let's say the bottom left corner of the chessboard is the origin. Now we have to understand that starting from the origin, let's say the slope of a line is m, which is given in the problem, and it's also given that m less than 1, that is a condition in the problem. So we have to understand here that how many boxes does the straight line exactly cross for a given slope m. Let's say this is a line of slope m. So we have to understand that how many boxes has this crossed. Now this is a chessboard, so it will have like boxes like this. I'm just showing you an example. It's a very horrible chessboard, but it's crossing some random number of boxes. It's a very random chessboard. It doesn't refer to a chessboard. It's not an 8x8. It's a very rough drawing. So ignore the drawing. But you have to understand that how many boxes does a line of slope m cross in a chessboard starting from the origin. So now we'll have a proper representation of this. So instead of taking a chessboard, I would rather prefer to take a graph paper, because it's the same thing. Taking a chessboard or a graph paper essentially just consists of grids. Okay, so now coming to the question, let's say we draw a graph. Now this is a miniature graph. It looks like a now this is a very rough diagram. As you can see, it's a 4x8. It's not a chessboard. It's a half of a chessboard. If you have the other half, you have the chessboard. But I'm just showing you that this is a rough diagram. And so we have this as origin. The bottom left corner as origin. We haven't taken the entire chessboard. The other half is obviously not drawn here, but it's just one half of it. But we'll try to analyze some points. If the slope of a line is given, exactly how many boxes does it cross? Now, if you try to analyze this entire situation as it has happened, this is an easy problem if you have the right approach. Now let's say this is a graph, so this will have some points 1, 2, 3, 4, 5, 6, 7, 8 along the x-axis, and along the y-axis there will be till 8. But I'm not showing that, I'm just showing one half of the chessboard. Now let's say I draw a very random line. A line with slope, let's say the slope of the line is 0.3. So for 0.3 I can plot the values here, 0.3, 0.6, 0.9 maybe, 1.2, 1.5, 1.8, 2.1 and 2.4. So the line looks somewhat like this. It's a very rough line. Don't take it seriously. I'm just trying to show you some interesting observation. That's why I'm drawing this line. So the line looks somewhat like this. and as you can see it crosses certain boxes. Now we just draw the table for this particular line. So the values, so let's say this is the x is, let's say 1, so the various values of x, we're just plotting the table for this function. So y has values 0.3, 0.6, 0.9, 1.2, 1.5, 1.8, 2.1 and 2.4. So these are the various values of y. Now I'll show you an interesting observation here. How do you calculate the number of boxes? Now you see from this table you can actually calculate the number of boxes that this line will cross. Now see, when x changes from 1 to 2, you will have a change in the grid, like you will have a change in the box. This is the box for x is equal to 1 and y is equal to 1, like this is the box. Similarly for x is equal to 1 to 2, you will have this box. For x equals to 2 to 3, you will have this box. For x equal to 3 to 4, we will have this box. For x equal to 4 to 5, we will have this box, and so on. So whenever x changes its value by a unit position, you will have a change in one box. See, 1 to 2, one box, 2 to 3, one box, and so on. So here for x, you will have 8 change in boxes. Okay, change in boxes. Here's the change. Now 8 for x only. Now for y, how many change in boxes you'll have? That's a very interesting observation right here. Now see what happens when the units place of y, you'll have to observe the units place of y. For example, the units place here is 0, here is 0, here is 0, here's 1, 1, 1, 2, 2. So all you need to do is observe the units place of y. Whenever the units place of y changes its value, that is, it is changing from 0 to 1 or from 1 to 2, this way, whenever the units place of y is changing its value, just remember that the number of boxes that was supposed to be changing will increase by 1. That is, see, look here, x is changing its value from 1 to 2, but the units place of y is remaining same. So change in box is only 1. See here. Now again, x is changing its value from 2 to 3, and the units place of y remains the same, that is from 0 to 0. So again only one box. But the moment x changes its value from 3 to 4, that is from 3 to 4, and y changes its value from 0 to 1 in the unit place, you see there's one extra box, that is this box as well as this box. Sorry, as well as this box. So there's one extra box, right? Again, when x changes its value from 4 to 5 and y from 1.2 to 1.5, the units place remains the same. So there's only one box. Again, from 1.5 to 1.8, there's only one box because units place remains the same. But the moment y changes its units place value from 1 to 2, you see there's one extra box, this and this. So one extra box. Again, from 2.1 to 2.4, the value of units place of y is same. So there's only one box, right? There's only one box. So total you have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes, right? Now see, x changed 8 times, so you have got 8 boxes for changing x. But y changed twice, that is from 0 to 1 here and from 1 to 2 here. For y, the number of changes is denoted by the change in its unit place. That is, y changed the value of 0 to 1 in its units place once, and again from 1 in its units place to 2 in its units place is changed once. So there are 2 changes. Okay. So for y, there are 2 changes. So 8 plus 2, you have got 10 boxes. That is what the graph verifies, that you have got 10 boxes. So all you need to understand here is, you need to look at the units value of y. If the units place value of y is changing from, let's say, any number to any consecutive number, then one extra box will be added. Okay. So from 0 to 1 there's one change, and from 1 to 2 there's another change. So overall there's 2 change in boxes for y, and there are obviously 8 change in boxes for x. So that is how you can say that there are 10 boxes. So now if you try to generalize for a chessboard, there are obviously 8 boxes as far as the x-axis is concerned, right? So in a chessboard, the question here asks that the path taken by Bobby will have to be exactly consisting of 12 boxes, right? That is given in the question, that it has to consist of exactly 12 boxes. Now, you know, for x you will get obviously 8 boxes. That is, for change in x from 1 to 8, you will get 8 boxes. So the question is, how many boxes do you need to change for y? Now since it is given in the question that it is 12, so you need 4 changing boxes for y. That is, you need 4 changing boxes here for y. Now you need to question yourself that how do you get 4 changing boxes as far as y is concerned? Okay, so the question here, the real question here is that you need 4 changing boxes for y, and as I have told you that y changes its boxes only when the value of its units place changes. So for 4 changing boxes, the value of its units place of y has to change 4 times. That is, from 0 to 1, from 1 to 2, from 2 to 3, from 3 to 4. Okay, so that's the thing, that it has to change its value 4 times, right? So you can say easily that whenever y changes its value 4 times, and obviously in a chessboard x will change its value 8 times, there are 12 times. Okay, that 4 plus 8, there are 12 boxes covered. Now that is what the question asks. So all we need to do is to understand how many times y changes the value. All we can do is we can take the function. Let's say suppose y is equal to mx is the function, where m is the slope obviously, and we can put x is equal to 8 and check the value of y. Okay, put x equals to 8 and check the value of y. Now if you see the value of y, since we need to have the value of y as 4 or more than 4, and not obviously not more than 5, because if the value of y is more than 5, then there will be another change from 4 to 5, and so there will be 5 changes for y, and 8 plus 5 is 13, so we won't get that 12 changes condition. Okay, so we need to have 13 boxes covered, we need to have 12 boxes covered. So we will make sure that the change in boxes for x is 8 and the change in boxes for y is 4. Okay, so to have only 4 change in boxes, the last value of y, that is the value of y for x equals to 8, has to be between 4 to 5. That is, the value of y has to be greater than 4 and less than equal to 5. Okay, so after doing all these things, we get a very simple condition right here, that the value of y, if we put x equals to 8 in this function y is equal to mx, then the value of y has to be between 4 to 5. If this condition is satisfied, then we will say that it is definitely a valid path for Bobby to take. That is, it is definitely a path satisfying the conditions given in the question. Now you need to understand that from where will we get the y is equal to mx, from where will we get the various values of m. Now that, as you can see, is given in the question. The question clearly states that the value of a, that is the slopes, various slopes values of Bobby are a by b, where a is less than b less than equal to 10, right? And for this condition, it's a very simple mathematical condition. You can have a various distinct set of values of a and b for this, and obviously it is also given that a and b are, I guess, co-prime. So that is also a very good condition. So now we'll have to see that what all conditions satisfies this, that is a less than b less than equal to 10 and a and b are co-prime. We'll get a set of fractions, and what we have to do is, from that set of fractions, we'll have to make sure that we form this equation y equals mx, and then we put value of x equals 8, and then we check that the value of y lies between 4 to 5 or not. Okay, so let's just do this straight away. That is, I'll take this condition a less than b less than equal to 10. Now b will have various values. The various values of b for this conditions will be 1, 2, 3, 4, 5, 6, 7, 8 and 9. And the various values of A, as it is given A and B are co-primes, the various values of A will be, as you can see, that the various values of A here, obviously you won't get a value of A for this, for B is equal to 1. There's no value of A for B equals to 1. You get only 1 for this. You will get the values of A as 1, 2 for this. A and B are co-primes, so here also you will get only 1, 3. Okay, here you will get all the numbers 1, 2, 3, 4. Here you will get only 1 and 5. Here you will get all the numbers once again 1, 2, 3 up till 6. You will get all the numbers. Here you will get only 1, 3. I hope it's visible here. 5 and 7. And as far as 9 is concerned, you will get 1, 2, 4, 5, 7 and 8. So these are the corresponding values that you will get. I hope you are able to see this one, or I can bring the board close. So these are the corresponding set of values that you will get for B and A. The corresponding values. Now all you need to do is just write down M here, that is the A by B form, as we know, that is M, and look at the various cases for M and see whether this condition is satisfied or not, that is 4 less than y less than equal to 5 for x equals to 8. Now I'll do the various cases for you, just hold on. Okay, so we can rub this now. Now this is the condition that needs to be checked. Okay, so the condition that needs to be checked is for x equals 8 if the value of y is this or not. So this is the condition. Now I'll do it for various cases. For example, for b equals 2, I'll start straight away. M is equals half. Okay, so I'll do this. Y equals half into x. Now I'll put x equals y. As you can see, I formed the equation y equals mx. So y is equal half into x. I'll put x equals to 8 straight away. That is half into 8. And I get y equals 4. Okay. So this is not a solution because we clearly need y more than equal to 4, but because y equals to 4, so it's not satisfying the condition. So we have checked it. This doesn't satisfy. So now I'll put m equals 1 by 3 and 2 by 3. So now I can write y equals mx. Now instead of writing y equals to mx time and again and putting x equals 8, we can directly write y equals 8m. Okay, I've just substituted the x to be 8, and we can just put the value of m and check if the y is between 4 and 5 or not. So again, y equals 8m, and where m is 1 by 3 and 2 by 3. So for 1 by 3 we get 8 by 3, which is not satisfying, and for 2 by 3 we get 16 by 3, which is again not satisfying because it's more than 5. So again, none of the conditions here satisfies. Okay, now we are going on to now y equals 1 by 4 and 3 by 4. Now for 1 by 4 and 3 by 4, once again it's 8 by 4 and 24 by 4. Now this is 2, this is 6, not between 4 and 5. So again this one also doesn't satisfy. Now we go on to y equals 1 by 5, 2 by 5, 3 by 5 and 4 by 5. Alright, so for y equals 1 by 5 we have 8 by 5, for y equals 2 by 5 we have 16 by 5, for y equals 3 by 5 we have 24 by 5, and for y equal to 4 by 5 we have 30 by 5. So here one of the conditions satisfies. This one, 24 by 5, the value of 24 by 5 is 4.8. So 4.8 lies between 4 and 5. So this one satisfies. So y is equals to the slope 3 by 5 this is a valid condition. Alright, this is a valid condition, 3 by 5. Now we move on to our next cases. So 1 by 6 and 5 by 6. For this we have 8 by 6 and 40 by 6. None of them satisfies. So again, that's a no. None of this satisfies. Now we go on to the cases for 7, for b equals 7. That is, we have to put a is equal to 1, 2, 3, 4, 5, 6. So we have to check for 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7. So 1 by 7 gives us 8 by 7. Similarly, 2 by 7 gives us 16 by 7, 3 by 7 gives us 24 by 7, 4 by 7 gives us 32 by 7, 5 by 7 gives us 40 by 7 and 6 by 7 gives us 48 by 7. Now among this, 8 by 7 doesn't satisfy, 16 by 7 doesn't satisfy, 24 by 7 doesn't satisfy, 32 by 7 satisfies. This value lies between 4 and 5. So 32 by 7 satisfies, which means that 4 by 7 is also a valid condition. 4 by 7 at slope, 4 by 7 is a valid condition. Okay. 40 by 7 doesn't satisfy, 48 by 7 doesn't satisfy. So we have got one case from here. That is, when the value of a is 4 and b is 7, that case also satisfies. So far we have got two cases. Okay. Now we'll do for the remaining values. That is, for b equals 8, we have got you have to put slopes 1 by 8, 3 by 8, 5 by 8, 7 by 8. So 1 by 8 gives us 8 by 8, 3 by 8 gives us 24 by 8, 5 by 8 gives us 40 by 8, and 7 by 8 gives us 56 by 8. Okay. Now among this value 40 by 8, this is equal to 5. So it satisfies our condition y less than equal to 5. So this is also a valid value. That is, we have got 5 by 8 as a valid value. So we have got one more from here. Okay. Now we'll go on to our last one. That is 1 by 9, 2 by 9, 4 by 9, 5 by 9, 7 by 9 and 8 by 9. Okay. So 1 by 9 will give us 8 by 9, 2 by 9 will give us 16 by 9, 4 by 9 will give us 32 by 9, 5 by 9 will give us 40 by 9, 7 by 9 will give us 56 by 9 and 8 by 9 will give us 64 by 9. Now you can check that only this value 40 by 9 lies between the condition for y, that is between 4 and 5. Okay, and the rest all values are either less than 4 or more than 5. So here also we have got one valid condition, that is the condition 5 by 9. Okay, this condition also gives us a valid path. So now we have checked for all the conditions and we get 4 valid conditions, that is 3 by 5.